PV is the name of the function. The first argument is the rate. That is a periodic rate. Okay. Uh, Things like yield to maturity are in APR terms. So I'm going to take the yield to maturity, divide that by coupon frequency. So if the annual rate that I'm using to discount future cash flows is 4%, to discount cash flow for only 6 months, I use 2%. That's called the period discount rate. The second argument is number of periods. Well, that's years to maturity times coupon rate. The third argument is payment, which is the periodic coupon payment. Well, we know how that works. That's the coupon amount, right? Take the face value, multiply that by the coupon rate, divide that by coupon frequency. And the fourth argument is finally face value. I'll wait for you to write that down. I mean, I'm going to make this available to you anyway, but you'll learn better when you do it yourself, hopefully. Are we all set? Well, it looks like this bond is worth negative. That's because uh, probably an accountant did the coding for this function. Accountants view things as debits and credits. So if you're getting payments for the bond, you have to be paying something. You know, payments are credits. Payments, what you pay is debit. But we know bonds are worth positive, so put a negative in front of it. Okay. Since I know this is a dollar amount, I'm going to make that a dollar amount. So at this, if the proper rate to discount this cash flow is 4%, this bond should be worth $1,081.76. By the way, such a bond is called premium bond. You should not attach the expression premium with some sort of positiveness or goodness. The only thing premium means the value of the bond is above the face value. Okay. If the proper rate to discount was 6%, I would get a value of 925 and some change. Since the value of the bond is below the face value, this is called a discount bond. At precisely 5%, come on. In fact, independent of the maturity of the bond, all bonds will have a value that is exactly equal to face value if yield to maturity is exactly the same as the coupon rate. Such bonds are called par bonds, right? A bond is premium when yield to maturity is below the face coupon rate. It is discount when it is above, and it is par when they are the same. In fact, we can write the following. And YTM is less than coupon rate. Premium or discount. Okay. There is another yield concept that you may see. It's called current yield. The only reason we ever calculate this, it's in spirit is equivalent to dividend yield of a stock. And let me use a different. That's annual coupon amount divided by the bond value. We haven't covered it yet, but when we cover stocks, we're going to calculate something called dividend yield. It's the expected dividend over the next 12 months divided by the value of the bond. So that's the only reason we would ever calculate that. It's not a true yield concept, but we could always say this following. For premium bonds, uh, yield to maturity is less than current yield, which is less than coupon rate. For discount bonds, coupon rates is less than current yield, which is less than YTM. There is actually an ordering to it. So if I ever ask you to calculate the current yield, all you have to do is find the annual coupon amount and divide it by the bond value. We could actually kind of put it here. Let me see. I'm gonna copy and paste it here. Annual coupon amount is face value times coupon rate. Divide the whole thing by the bond value. Obviously, when a bond is a par bond, all three are equal to each other. So for, as you can see, current yield is above the above the yield to maturity, but below the coupon rate. Or if I'm discounting at 6, current yield is above the coupon rate, but below the yield to maturity. Since this is a computed thing, let me copy and paste formats. I mean, I put 5 digits. Why? Because it's my sheet. I can do whatever the hell I want with it. It's, I like showing more details than necessary because sometimes if I put only 1 digit over there, I may be missing something. Nobody ever got hurt by displaying some insignificant digits, right? Now, uh, okay, I still have 30 minutes. So anytime if you have this sheet, and I'm going to actually go ahead and post it as it is now. So if you want to work on it, you could. I'm going to put it under course documents for now. Bond value template. Of course, Excel is going to protest and ask me to close it. Browse local files. Submit. Again, I'm going to open it. Let me see, it's going to Protest again. Yep. So open where the file is, right click properties, and you do this only once. Okay, and I'm gonna just open it back up and make sure you enable the contents. That's gonna matter for the sort of stuff we're gonna do. Now, so if I ask you a question about calculate a value for a certain kind of bond, you should be able to do that. So let me do, assuming you were interested enough to open the file. Calculate the value of a bond, 30-year bond. Face value equals 1,000, semi-annual,